What up, Bread fans? How you doing? How you living? I hope all is good in your neck of the woods, wherever those woods may be planted. We appreciate it. We appreciate you taking the time to be here. It's just me today. Got a few thoughts on some interesting research stories that crossed my desk, and we got some questions on the mail feed that we're going to get to. But before we do that, as always, follow us, rate us, subscribe, wherever you get your podcasts. Leave us a review and a rating. That really, really helps us out, really helps the visibility, boost the show up those charts. Reach out if you want your question read on the air. Twitter, @2BradForYou. Instagram, @2BradForYou. You can send me an email, 2bradforyou@gmail.com, and you can leave us a voice message using speakpipe.com. Speakpipe.com/2bradforyou. All of this can be found on our website, 2bradforyou.wordpress.com. Links to all of those things. You can even use the comment form there if you want to get in touch. Please do. Trying to, get you involved in the show. Want you to help me find topics, make this better, address the things that you want to hear about. I'm working for you, people. So take advantage of that. All right. Having said all that, let's get into it on this Monday afternoon, this lovely Monday afternoon over here in Marburg. All right, first and foremost, like I said, I got a couple research stories that I want to lay out for you that came across my desk before we get to the questions. And the first one is somewhat related to babies, which I now have one. You may have heard. I am a father. I have a young infant in the house. You might even hear him crying in the background while I record this. Hopefully not. He may be sleeping. I'm not sure. My lovely wife Teresa is taking care of him while we do this little chat. So shout out to her as well. If you've talked to parents before, new parents, you've probably heard all the same cliches. They grow so fast. Oh, it's amazing. All of these things about having a kid and what a trip it is to watch them grow. And it is. It's a real trip to watch them grow. And so I've got a couple thoughts on that will link into this story, as you will see. But first off, the thing that has tripped me out the most about having a kid is milk. Like, holy moly, how can a 6-kilogram living thing survive only on liquid? It blows my mind. I see this little guy chugging back this bottle or feeding from his mom, and it's just insane to me. Like the feeling that he must get, the full stomach he must get, only living on milk. I mean, I've drank too much beer before, and I know that bloated feeling, and it's terrible. It's just not fun. But this is a baby all the time, which explains, probably why he needs to burp and spit up everywhere. And it speaks to how nutritious mammal milk is, which is the thing that's just kind of blowing my mind. The evolution of it, it's amazing. The fact that females can produce this like most nutritious drink just on their own. I've talked about this on the podcast before, but you'll find these weirdos in the corner of the internet, these real nerds that are just like, you know what? Eating food is too much work. It takes up too much of my time, and I don't want to do it anymore. So they spend all this time trying to make these like Soylent Green, nutritious, all-in-one drinks that they can just drink all their nutrition every day. And it's stupid. But the fact that the human body already makes that, or the mammal body already makes that, for your first however many, months of life, year of life is it's pretty incredible. Like I'm holding this, like I said, a little like 6-kilogram human being, and I'm I think of like there's like a dog or like a pug or a little terrier or something that's about the same size, and it's like you wouldn't imagine just feeding them liquid, them just surviving on liquid. Like it seems crazy. But then I think of a whale. Like a humpback whale calf can be up to 4.5 meters long and weigh a ton, and it will only drink milk for a whole year. That's so much milk. there's so much nutrition, there's so much fat. I think the whale milk has like 40 to 50% fat content. Like it's just, I don't know. I digress. Because like even aside from the nutrition, I've been working on a project that's involving a literature search of microbiome research, and milk plays a huge role in the developing microbiome too. So not only is it this like crazy nutritious thing that we've evolved to survive on, um, it also plays such a role in establishing the microbiome of your body, of your gut, which I'm finding out now, like I'm getting blown away now by the level of communication that goes on between gut microbes in our body. Doing this project, it's crazy. The microbes actually direct the development and function of immune cells. So like without them, your immune system just wouldn't function properly. They secrete these proteins and metabolites, all these other things that like specifically regulate your immune system and kind of train it. It makes it kind of uneasy to have, the level of reliance that we have on this bacteria living in our crap factory. Like we owe them. And I don't like that. I don't want to owe the bacteria living in me that much, but we do. And I digress even further because, yeah, now we're now we're off milk onto microbiome. But the second thing that I'm finding to be a real trip with babies is watching their brains develop. And that's obvious, like I said, there's all these tropes about, you've heard it all from parents, when they start to notice things, when they start to laugh, when they start to talk, all of these things. I get into these conversations with my parents and my lovely wife, Teresa, where we're all saying like, I wonder what he's thinking. You see him do these cute things, these cute pictures, and you're like, what's he thinking? He tries to react to things and he's babbling and you can kind of see the wheels turning, but you're thinking like, at what level? At what level is the thought that's really going on there? Is it just like this sort of instinctual response to stimulus or something? I mean, they don't have language. So even if you could read their thoughts, what would they be? You would have to, have a hypothetical brain reading machine that could translate, these waves of emotion and stimulus and response and stuff into language, But how does the baby itself experience and interpret this stuff? What's going on in its head from moment to moment is, we could sit here and speculate all day, but I assume, most people are thinking in dialogue. Maybe I'm wrong, but, these babies don't even have the option to think in dialogue. Maybe people who are born deaf, maybe that would be like an example of people who don't think in dialogue. But anywho, this is what led me to something I saw the other day that is the first little bit of fascinating research. And I'll get to the infant brain connection in just a second. But first, I got to start by talking about organoids. I'm not sure if you've heard of organoids. I'm fairly positive we've talked about them on the show before. But basically, these are stem cells, little clusters of stem cells that can be stimulated in a lab to grow small 3D structures. And because they can be controlled and grow in a 3D, in the third dimension, so they can, not just on a flat petri dish, they can grow up and around, you can create little organs. You can direct these stem cells to start growing liver tissue or nerve tissue or, in some cases, brain tissue. And the cells grow together in a way that they would in the body. And they self-organize into these sort of complex 3D structures similar to that of an organ. Now, obviously, they aren't full replicas or functioning organs, but they are mini test versions that you can use for research, which makes sense, right? You don't need animals, which is ethical, and the cells are human, so the gaps in interpretation that happens when you do animal studies, like that's gone. So if you test toxicity of a drug, for example, on a liver organoid, you don't have to worry about killing anything, an animal or a human, And you can see how the human cells, how the human tissue actually reacts to that drug, and not have to be like, okay, well, that was in a pig or that was in a rat, so is it going to be the same, and all that kind of stuff. But here's where it gets weird, because liver, fine, no qualms. I don't think anyone has really any objections to drugging little mini livers. Nobody cares. But what about mini brains? And like I alluded to, there are brain organoids. You can direct stem cells to grow as brain cells, and they will organize into little lumps of brain tissue and form tiny brain-like structures. And so the bioethicists looking into the future, of this research, have of course raised the question, at what point can these things become conscious? At what point will they get sophisticated enough and big enough to feel pain or discomfort? And will we know? Will we know when that is possible? Because these things, if they're not connected to some kind of means to vocalize or communicate, or like a keyboard, they don't have hands, they don't have vocal cords. But if they had they were plugged into some kind of interface where the thoughts could be translated, much like I was just talking with the baby brains. What would you all of a sudden get a message being like, this sucks. I'm a little brain that's been brought to life in this jar, and it's fucking boring. Weird. It's a weird thought, right? And so, like I said, there's no evidence that these things are conscious or that they do feel pain or anything like that. But like, extrapolate and it could get real weird. Which then brings us to the infant link. Because here is a headline from fiercebiotech.com. Miniature brain organoids found to mimic early infant brain development over time. That's right. They're growing infant brains in jars. You heard it here first. The eggheads in the lab over at UCLA and Stanford reported that the growth and development of these little brain organoids closely mimicked that of babies. So what they did was they looked at the genes that were being expressed in their little brains and jars, their little organoids. So the genes that were being turned on and off over 20 months as these things grew in the lab. And the pattern of expression, the pattern of genes and gene products that they saw followed what you would see in a real human being in the states of pregnancy through to birth and into infancy. So according to the researchers, no one has grown these things for this long and tracked the development and realized that in the lab environment, it mimics human development. So Aaron Gordon is a postdoc and lead author of the study. He says, quote, "This is a remarkable finding. We show that they reach postnatal maturity around 280 days in culture, and after that begin to model aspects of the infant brain, including known physiological changes in neurotransmitter signaling." Whoa. So these things are on their way to developing as an infant would, which makes sense because they're stem cells, they're human stem cells, so they have that sort of cellular programming. It's in the genetic code how they're supposed to develop. So it makes sense that would be, if you leave them long enough, that they're going to start going through these phases, The article goes on to say that the researchers believe that with a, quote, little bit of a push, these things could be used to study diseases that appear much later in life, like dementia. So that's, the use of it. You can not only track development and look at developmental disorders, probably like autism and other things that we notice earlier in life. But yeah, if you can keep them sort of alive long enough, I guess we'll say, or even if you could have like proxies of the amount of time. So it, maybe it doesn't have to live 80 years. You don't have to keep this thing in a jar for 80 years, but like because the size is smaller, or the environment that you keep it in is in such a way that you can mimic 80 years of development or time passage or whatever in, however many months or something. I don't know. I'm speculating here, but you could see how that might be the case. But the thing that really jumps out to me is that even in a lab environment, you get this human-like development, right? So, as I mentioned, makes sense. There's the cellular programming that would kick in, and it's only got one or so path to follow. But we know that gene expression is altered by or influenced by environment, right? So that's why I'm assuming they're using these words in their quotes and stuff. The researchers said it mimics infant development. It's not exactly the same because you don't have the exact same environment. But what if you did? So in a lab environment, just in a dish, these cells already start to grow like an infant brain. But what if you did just even a little bit to sort of recreate the womb environment, added some of the hormones that might be there, even mimicking the light and the sound of being in the womb? How would that impact the development of these brain organoids? Would that be pushing it along towards consciousness? The more you made it like an actual womb, the more you would get a more human-like little brain. I don't know. What would you see? Now, that is some pretty hard speculating, but I think that's how you would do it. And it's wild, wild stuff. Obviously it's great to have models to help people suffering from diseases and, to have better understandings of how things like autism and that develop. What are the genetic components for conditions like that? Because hint, hint, it's not vaccines. But I will admit that it is a little freaky. It's a little weird. And when I first saw it, thinking of, like I said, looking at my infant and seeing how his brain is starting to put things together and stuff like that, and then thinking about a brain in a jar that's maybe on the same path, it's a little wild. It's a little wild. And I am going to get into some other freaky research in just a little bit. But first, I want to check in with the mail feed. Dialing into the mail feed. Got a bit of a slow connection here, so just bear with me. And there we go. Mail feed accessed. What is going on? Well, we have some Twitter chatter. Got some Twitter chatter on the mail feed. So we have a specific question, and we had some conversation action going on surrounding some of the topics that came up in the last couple of In Conversation episodes I did. So open science, preprint, those things that came up when I spoke with Martin Nielsen and Stephen Doyle. So I'm not going to rehash the whole conversation, and I recommend that you listen to both those episodes. I think they are 19 and 21 of the In Conversation series, Martin Nielsen and Stephen Doyle. They both raised really good points on the pros and cons of how science is published, whether it's preprint and then eventually onto peer review or just peer review. There's pros and cons to both. And we had a really nice, I had a really nice chat with both of those guys about that. But the latest back and forth on Twitter resulted in Martin posing this question, which I think is an interesting question. He framed it as you could use this as a potential panel topic, but the question really struck me, and it was, can the general public truly benefit from watching science happen in real time? And my gut reaction was that in the context of the Rona, the answer is no. Because a lot of the miscommunications, misconceptions that have taken hold during the Rona pandemic, vaccine risk, the changing of guidelines on masks and things like that, this is people watching science unfold in real time and maybe not understanding the process, or having other people twist what is a bumpy, process that doesn't occur in a straight line to their own narrative. And so, no, maybe there isn't a benefit to the public sort of watching all the messy details of science play out in real time, because it does take a long time. It can take a long time for definitive answers to come through, or I mean, I guess it depends on your time scales, right? Because the fact that we have the mRNA vaccines so quickly for coronavirus on one hand is a very short time frame, like about a year, but then you have to look at the larger time frame of the decades that went into that mRNA technology research just in general to get us there. So I think I'm a little torn on that, and I think it's a really interesting question. So depending on the situation, I could say no. I could say yes, but with the caveat that you have to understand what it is that you're seeing play out in real time. You have to understand that the first results might say something that will change in the future. Like, you have to have that in the back of your mind and that understanding always going into this. Otherwise, watching it play out in real time is you're just gonna say, oh well, it's flip flopping. Oh well, it's always changing. What can we even say here? There's a lot of uncertainty in science because it is a process and a never-ending process that's constantly updating. And the problems that I've outlined are my misgivings with the idea of people benefiting from watching science happen in real time might just be a greater indictment on communication and a realization that we need better science-specific communicators. And the optimistic science sort of advocate in me wants to say yes, the general public should benefit and can benefit from seeing science in real time. Again, with this caveat that there's good communication and an understanding of what that process is that they're looking at. Right now, science isn't reported in real time. I mean, we're kind of getting that with the coronavirus pandemic, like I said, but you're lacking a lot of context and that kind of thing. And, usually we're so used to science being reported in this sort of like breakthrough thing, right? Scientists had this breakthrough and it means, this, and in another 10 years, we're going to cure cancer and blah, 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 all that stuff. Like the timelines are not really accurately represented, and there's a reason for that. It can be difficult to do when you're trying to do just like a short news piece or something like this. I mean, there's lots of excuses, but I think in general we could improve that, but it starts with your audience having an understanding of how science works and the timelines that are involved, and each set of research is going to have different sort of timelines. Physics and chemistry and biology will all be different. Just the ultimate understanding that it's a never-ending process. So you can watch the process unfold in real time, and we can get breakthroughs along the way, and we can get usable intelligence along the way, and we can get translatable knowledge along the way, something that'll lead to a product or an invention or a drug or something. But a lot of it we won't know what the meaning is till years later, right? When someone else from another field comes along and says, oh, hey, that guy did this with brains in jars over here, but maybe if I had just kind of tweaked that and used it for this purpose, we get a whole new thing. And I've talked about this a lot on the show, the importance of basic research, and open research is certainly a part of that, because it will help you, not just the public, but collaborate with other researchers, right? So other researchers need to be able to know what everyone's doing. But anyway, that's probably even more than I wanted to spend on that topic. Because I think it's better served, like Martin suggested, is me putting it out to other people, communicators, academics, etc., rather than just me sitting here rambling on about it. But really interesting question. So I want to thank Martin for that. And then we will move to a specific question on the Twitter feed that came in from friend of the show at Vandareldon. What up, Vandareldon? Thanks for the question. And at Vandareldon asks, are mushrooms and ayahuasca the only two hallucinogens that are being used in therapy? And what are the ins and outs of use of these substances where legal? Is it being sold for recreation? So again, thank you for the question. Appreciate that. I'm assuming this is dovetailing off of the In Conversation episode number 20 that I had with Shayla Love, a senior writer with Vice, who is doing great reporting on the sort of legalization, commercialization, patenting of psychedelics and psychedelic therapy. But let's break this down a little bit, because the first question, are mushrooms and ayahuasca the only two hallucinogens that are being used in therapy? I assume Van Dereldoon is referring to the clinical studies on depression, etc., that you see in the media. And for these, MDMA and psilocybin being the active ingredient in mushrooms and magic mushrooms, are the main ones, and they're being used to look at PTSD, mainly with MDMA, and depression with MDMA, but mainly psilocybin. And the MDMA therapy for PTSD has been pioneered by MAPS, the Multidisciplinary Association for Psychedelic Studies, I believe, in the US. And the mushroom work has largely been going on all over the world. There's a number of groups. Germany, the group in Germany here that's associated with the Mind Foundation that we've talked about on this, that I went to their conference and made an episode about that. They just got approval on their big study. So I think that's going to be one of the biggest studies on clinical depression and psilocybin in Europe. Yeah. So yeah, those are kind of the two main ones that are in the clinical research domain. And there's a couple reasons that they're the popular ones. First off, they appear to work. So like I said, MAPS has been doing work with PTSD and MDMA for a while, and they've shown a lot of positive results. And then the same thing with psilocybin. A number of groups have shown sort of this link, this positive results. So other people are just replicating that work, right? Once one person finds something works, then you want to replicate it on and on and on. That's the process of science, constantly refining it. So yeah, it appears that they work. But there's also practical reasons as to why these ones are used, or at least were investigated. And then once they found out they worked, I kept going. LSD had been used when it was first discovered. So back in the 50s and 60s. Originally, alcoholism and addiction was the conditions they were trying to treat. Limited amount of success, conflicting results. But the trip is quite long with LSD, longer than mushrooms for sure, and MDMA. So while LSD might have similar effects as psilocybin, not exactly the same, but you could say similar, and you could see how descriptions of the drug state, the altered state of consciousness on both of those, you could be like, okay, that's kind of similar. I could see where if you're going to use one for therapy, you might use the other. But when you think about just the length of the trip, it gets expensive, because you need to have, your person in the clinic supervised by a therapist and stuff like that. So if you're talking like a potential 8 to 12 hour LSD trip, or like a 4 to 6 hour mushroom trip, it's it that adds up, right? So there's actual practical reasons as to why these are used and not others. So there is some studies that have looked at DMT in a clinical setting. I don't think they've done like randomized control trials with the DMT. I think one might be coming out. LSD, like I said, and others. From my understanding, DMT doesn't show the same therapeutic value at the moment. It's a very intense trip, so it's been used in the clinic, in a clinical setting, we'll say, just as sort of exploratory, observational studies. This was the Rick Strassman work, and they injected it via IV, which a better way to control dose and stuff like that, as opposed to just smoking it. But then again, it requires a trained staff to do injections and dosing and all this. LSD again has a long trip, time and may not show the same efficacy as mushrooms. But there, like I said, there are still people researching these. I think LSD has also been used more often in what they call psycholytic work. So this is where therapists are like more engaged in guiding the trip as it happens. So they're trying to, it's like more intervention. A lot of the stuff with psilocybin and MDMA, if you listen to the episode of the Undark podcast that I did covering this topic, they describe how generally the accepted mode of therapy with psilocybin and I'm gonna say MDMA because I think it's the same. I think that a treatment model has largely come from the MDMA work by MAPS, but it's a very hands-off approach. So the person takes the drug. The therapist is there to sort of reassure them if they get scared, that kind of thing. But they generally don't really interact during the trip in a sort of therapy way. That's done before, when they sort of set the intention, what's the goals for the trip, what are you trying to achieve with this kind of thing, with this experience, and then afterwards in a process called integration, where you then sit with the client and you're like, let them sort of explore what they felt, what they saw, what they experienced, and try and find some meaning, and you sort of maybe nudge them along in terms of helping them find that meaning. But psycholytic work is like the opposite. So they're really a lot more engaged. And that's been done with LSD. And there's an institute in Switzerland that does this. I'm not sure if it still exists. At least they did do it. But they also ran into safety concerns with this approach. So I'm not sure if that's still going on. But yeah, so mainly the stuff that's going on in clinical trials is MDMA and psilocybin. But there is a but. There are also so-called naturalistic studies. So this is where researchers go to places where, like ayahuasca ceremonies are allowed, or where it's legal to do mushrooms, or people are just doing it regardless of the legality of it. And they observe. So they do interviews, this kind of stuff. It's more of an anthropology approach, to sort of describing and understanding what's going on with the drug experience, the altered state of consciousness, the participants, and all that in a real life context. So obviously this doesn't have the same rigor and control of the clinical work, but there is certainly value in it, especially when you think about the influence of set and setting, the ritual nature of ceremonies that could be happening in these groups when people are doing these things in groups or something, going on a retreat, that kind of thing. But if you want to say this is a viable treatment for, this disorder like depression or something, then yeah, you need the clinical, you need the rigor of the clinical trials. I would argue you need both. A lot of people argue that you need both, that both have value. Because again, like I said, set and setting, again, in that Undark episode that I reported, we learned that set and setting is such an important element of predicting sort of the outcome of a trip, whether it's going to be good or bad, or the type of experience you can have. Like the range of experiences you can have on a psychedelic are massive. So where you are, who you're with, those kind of things are really going to play a role in that. And so these naturalistic studies where you're just observing an ayahuasca ceremony or something, for example, is really valuable to understand how those things play a role in the experience, and then what the person gains from that experience. There's a really interesting story is maybe the wrong word, piece of research about placebo with ayahuasca, though, that I will share with you as well. So again, one of the problems with doing clinical research that we learned about in the Undark episode is when you have a psychedelic, it's such a powerful effect that if you give someone a placebo, they know that they're not on mushrooms. It's pretty obvious that they got the placebo, and it's obvious not just to them, but also the doctors, right? And so then it just adds a potential bias into all of the trial, and there's issues there. Now, you can trick people into thinking that they're on a psychedelic. That's possible. That's been done. But the other thing that they try and do is give you active placebo. So give you a placebo that does something to you, so that you, sort of don't realize that you're in the placebo group. And with ayahuasca, because it's a drink, it's got a very strong odor, very strong taste, makes you vomit a lot, usually, this kind of thing. You can simulate that. You can simulate that beverage, something that's going to make you have diarrhea, something that smells and looks the same, something like that. And researchers did that in a trial. And a lot of people that were in that trial weren't able to distinguish whether they were on the placebo drink or not. So just kind of interesting. Another avenue of psychedelic research that is totally fascinating. Placebo and the fact that you can trick someone into thinking they're on a hallucinogen and that kind of thing. It's all about expectation and setting and that kind of thing. So that's just a little interesting aside. Now, the second part of the question, legalization. So what is going on in places where these things are legal? Well, technically, if something is legal, you can do whatever you want. If it's legal, you can use it recreationally. Therapists can use it with their patients, so long as there's, sort of guidelines, put forward by, say, the Psychiatric Association or something like that. But if it's illegal, you can do whatever you want. You can sell it, you can grow it yourself, use it alone, with your friends, whatever. But obviously there's levels to legal. Think of weed. In Canada, for example, it's legal to buy and sell marijuana and use marijuana, but there are still restrictions on how much an individual can grow for personal use, for example. It's a lot, but there are still restrictions. And you need a license to sell it, So it's legal, but there are some regulations, right? Mushrooms would be the same because they grow naturally. So anyone can find them depending where you live. You can grow them too. So individual laws in the different places will range from decriminalization, meaning you won't go to jail for possessing these things, growing these things, consuming these things, to full-on legalization. And there'll probably be a mix of things in between. Wikipedia has a page that lists by country the different stages of legalization in all around the world, if you're interested. And so then aside from legalization, you have the so-called medicalization route. And I'm guessing that maybe this is where the question is stemming from, because I even get confused on this kind of distinction. So the medicalization route, this is what the clinical trials are aiming for, or are designed to, they're part of that process. And it leads to a situation where the substance is still illegal for recreational use, but it can be used in a defined medical situation. So you have the clinical trials that build up this body of evidence that say, hey, this substance is illegal, but we've got proof here that it is useful for the treatment of depression. So you then can get medical approval. So the regulatory boards say, these substances can be used or prescribed by doctors, therapists, whatever, for these conditions. And the scope of their decision will dictate how widely available that is. So again, I discussed some of these issues with Shayla Love on episode 20 of the In Conversation section, on the In Conversation section of the podcast, and covered it in this Undark episode that I did. If you go to the Undark podcast, Undark Magazine podcast, you'll find that episode. And it's what the regulators say you can and can't do will really define what makes this available. So, for example, they could say, yes, we will allow therapists to offer this psychedelic treatment. We'll call it, they can only use psilocybin in these amounts. They have to provide X number of hours of therapy beforehand. Then they can do 1 or 2 trips, and they have to have X number of hours of therapy afterwards. For example, that's just, I'm just kind of making that up, but that could be what the regulatory boards say. And then that's it. That's all you can do. That's all that will be allowed. And then the different therapists will be able to do that. If that treatment protocol that I just laid out is patented, which some people are trying to do. Some people are moving towards patenting their therapy manuals, their therapy conditions, that kind of thing. Then therapists, clinics, or whoever wants to offer that therapy will have to get a license from them, pay them, to do that. So all of that kind of stuff is going to decide what you can do in a space where things aren't just completely legal. And what's, sort of approved medically will also be what you can get reimbursed for from insurance. So it plays a role in that as well, this medicalization route. What are health insurance providers going to cover? They're probably going to cover something that's been sort of approved medically. You can also advertise it then as, like we have, this is an approved therapy. So it gives it that weight that we can advertise it to doctors, the people, if it's a drug, if it's a pharmaceutical drug, you can sell it to doctors, and they can prescribe it, that kind of thing. If it's a therapy model, same thing, right? You can advertise, hey, we have the FDA approved psilocybin therapy. Here's our manual, that kind of thing. So yeah, those are the two sort of routes that these things can go. And again, think of marijuana. For a long time, it was available medically before it was legal. So in those conditions, you had to see a doctor. The doctor had to say, yes, you fit the definitions of what the medical regulators have said is a valid condition to get a prescription for weed. And maybe that's how psychedelics go too, where they just say, hey, it's medical use, so you can just get a prescription for it. You don't need to go to therapy and have that component of it. Now, I don't think that that's how it will go. I think it's way more likely at this point that if medical approval gets granted, that there is going to be stipulations on the therapy angle of it, which makes sense. But that could lead to full-on legalization. Decriminalization is already happening in a number of places, meaning that people, there'll be less hoops to jump through in order to do this kind of research as well. Like therapists will be able to sort of talk with their clients about this and say, hey, if you're doing, mushrooms, this is a way to think. We can talk about it, or we can, do the integration session or something afterwards. Kind of going off a bit on a limb here because the space is wide open at the moment. But broadly speaking, that's the sort of the situation. You have something's illegal, so you get arrested or whatever the penalty is for even, having it, growing it, whatever, selling it, all of that. Decriminalization, so you're not going to go to jail, but there's still, a fine or something. It's not technically legal. Then you can get legalization with, different caveats as to how much you can have or how you can sell it, where you can sell it, that kind of thing. So it's like any other substance, alcohol, tobacco, there's rules on all of it, right? And then there's this medicalization route where people they're trying to get the substance medically recognized as beneficial. And that could, that's a good thing, because it has the evidence of what, that the thing works. You can be sort of, we're not going to enter just this like, wellness space where anyone can say anything about diets or whatever. So you can't just say anything about psychedelics. It's going to cure everything. You kind of have some evidence behind what people are saying, and that will probably, in my guess, push. If you get medicalization first, it will push towards legalization. All right, so I hope that answers the question. Very long answer to a short Twitter question, but that's what you get on this podcast. You ask your questions, I give you what I got, which is rambling information. Now, I want to touch on two other stories. Like I said at the beginning, some more freaky research going on, and I think I have just enough time to throw them out there and then let you sit with it. Maybe it disturbs you. You can deal with that for the rest of the week. You can send me your thoughts, questions. We can pick up on it on another episode, perhaps. And so first, we're going to link to the brains in jars because the headline from Live Science is part human, part monkey embryos grown in lab dishes. You may have seen this last week. I think The Economist did a piece on it too. Those eggheads in the lab have created human-monkey hybrids. Chimeras, as they're called. Now, before you get the image of, an ape man, Neanderthal-looking thing escaping from the lab, it is not that. They're embryos. They're not kept alive that long, only 20 days in lab dishes, but they injected dozens of human stem cells into developing monkey embryos, and the hybrids survived for, like I said, 20 days. So the idea is that these could someday serve as helpful models for human disease, embryonic development, aging, all that kind of stuff. And when you think about what we had talked about before with the organoids, it's kind of like, well, why? Why not just do that? So obviously different researchers are doing different things. Everybody's trying a different method to see what works best. But the overlap in terms of what you might be looking for in terms of development or conditions, diseases that you would be researching, it would be similar, right? Like if you can get some kind of a living model that's not an animal, that's not totally animal, the implications are going to be the same. But specifically, the human embryo hybrids here could also help when we're talking about trying to figure out how to grow human organs in animals for transplants. So that's sort of a unique aspect of this research. And obviously, there is major ethical implications, just as there was with the little brains in dishes. How long can you let these things develop? Is it ethical to let it come to term if it's got human cells in it, even if they're like not in the brain cells? I think we talked about this in a way older episode where they were doing this, something similar with pigs, right? Where you're growing human organs in pigs using stem cells and stuff like that. So you actually have actual human tissue in another animal. Is it all right as long as those stem cells don't get into the brain and the brain of the animal become more human? That's the kind of question that you would want to grapple with, and that's really what they want to try to avoid is the brain just becoming more humanized. Maybe in the embryo research, maybe that is the ultimate goal, is to kind of have a brain, a view on the brain, like the human brain in the context of the rest of it. I don't know. And frankly, the chimera thing is creepier to me than the brains in jars. I don't know. There's something about it because I guess because it's chimera, because it's man and monkey, man and animal together. What's that science fiction book, Dr. Moreau, The Island of Dr. Moreau? I don't know. There's something weird about that. rather than just sort of growing like even if we take it to the extreme and we grow sentient, brains in jars. Um, but anyway, a little bit of freaky research there. I thought it was kind of interesting. I'll link to the Live Science piece and the Economist piece so you can kind of dig into that a bit more. We've been going for a while here, and I want to hit one more story, which might actually be the most interesting one we talk about today, and that is COVID-19 reinfection trials in humans will be happening in Oxford. Whoa, right? I know. I'm sure there's some conspiracy theorist channels out there. They're going to be all over this human experimentation on COVID or with COVID. And yeah, that is what's happening. So the goal of this stuff is to learn about the likelihood that people who have had COVID-19 can get SARS-2, can contract the SARS-2 virus again. And if they do, what's the immune response? How sick do they get? That kind of thing. It's going to be going on at the University of Oxford. They've announced the human challenge trial so that they can gather this sort of data to understand reinfection. It's going to be done under obviously carefully controlled conditions for research purposes. But, it's weird. It sounds weird. Sounds uncomfortable. And I get that. They're going to use the original SARS-CoV-2 variant, so the original Wuhan virus. And like I said, there's a value to these studies in understanding exactly how the immune system is going to work if someone gets reinfected. I mean, we have this sort of anecdotal evidence. It's not anecdotal in some cases where you can be like, that person was confirmed and they confirmed positive again. I guess there's always some ambiguity there as to like, was one of the tests a false positive? Was it just late? Was it just they never recovered from the virus and then it came back kind of thing? We don't know. So doing something like this gives you a much tighter control of the situation, so you can sort of understand all of these different nuances a lot better. So that's why you do it. I mean, like I said, it does sound like why the fuck would you do that, and who the hell would volunteer for it? But there's volunteers for it, and I'm assuming they get paid. They must get paid. But anyway, I don't have those details. Just a little bit about what they're actually going to do. There's going to be 2 phases. Phase 1 is 64 healthy volunteers aged 18 to 30 who have all previously contracted SARS-CoV-2. Half of those are going to be used, or sorry, not half. The first group is going to be 24 individuals, and they're going to get exposed to increasing amounts of the virus. And that's going to establish a dosing threshold. So at what point does reinfection occur? Like at what point does the virus establish again in you? And then once they have that number, they're going to administer that amount, that optimal dose to the rest of the group. They're going to be isolated in a special designed hospital suite for 17 days. They're going to get the best care, obviously, and all these tests are going to be done. They're not going to be allowed out until they're no longer infectious. If they develop symptoms, they'll get monoclonal antibodies, which is a treatment for SARS-CoV-2. And then they'll do all these follow-up examinations over 12 months. So, things they are hoping to find. I'm just going through the Medical News Today article about this right now. So optimum dose for reinfection is the big question that they're going to answer. And I imagine that they will also be able to look at antibody production, that kind of thing. And what kind of factors influence what is the likelihood of getting infected again? So your genetics, background, health status, severity of your previous infection, time since that previous infection, all of that kind of stuff. So in phase 2, one of the professors involved in the research says they will, quote, explore 2 different things. First, we will define very carefully the baseline immune response in the volunteers before we infect them, end quote. And then with this information in mind, quote, we will then infect them with the dose of the virus chosen from the first study and measure how much virus we can detect after infection. We will then be able to understand what kind of immune responses protect against reinfection, and we can measure the immune response at several time points after infection so we can understand what immune response is generated by the virus, right? Okay, so yeah, phase 1, you find out what it takes to reinfect someone, and then look at some of the differences in the people, those things I've mentioned: genetic background, health status, severity of their previous infection, and time since initial infection. And then phase 2, we look at the immune response to the reinfection. Crazy. I don't know that I would want to volunteer for that. Like I said, depends on what the pay was, because I assume you get paid, compensated in some way for this. But it just sounds crazy, right? Like you see a headline where it's like, yeah, we're going to reinfect people with SARS. These people already had it once, and they're signing up to do it again. So it was noted in the Medical News Today article that one of the professors they spoke with, who is not involved in the research, but he was giving comment on the importance of the research, went on to say, he went on to commend, quote, the bravery of the volunteers and medical professionals involved. And I think that is a great place to end it. Those people are incredibly brave. So we will actually be following up on this, because I am very curious to see how this all plays out. Let me know what you think of anything that you heard. What freaks you out more? Human experimentation with SARS, monkey human embryo hybrids, brains in jars that look like infant brains, psychedelic therapy, open science. Man, we covered a bunch of things today. So let me know what you think. Hit us up, as always, at 2bradforyou on Twitter and Instagram, 2bradforyou@gmail.com if you want to send an email, and you can send a voice message, speakpipe.com/2bradforyou. We will address your comments on the show. We will play your voice messages on the show. Rate us, subscribe, like, leave a review. That stuff really helps. We appreciate it. That's all I have. I'm hoping that Brad will be available to reunite with me for an episode soon. We've been in the works, negotiating his contract right now. And yeah, thank you so much for being here. Love the fact that you're enjoying the show, that you're a listener. Yeah, I'm speaking to you, directly to you. Thank you so much. I appreciate it. That's all I have. We'll see you next time. Bye for now.